Okay, guys, welcome back to my new lecture video on deterministic finite automata. Let us see one more problem on deterministic finite automata. So the problem is, it says construct a DFA which accepts strings of only A's. See here I have only one alphabet A, such that the length of the string that is, if I consider W as a string, the length of W should be divisible by 2. So this is what the question says. The same question can be asked in other way as well. What it is? Construct a DFA for accepting the strings on A's which is having even number of A's in it. Even number of A's in it. So these are the two ways of asking the same question, which can be written as construct a DFA for the language L is equal to W, where length of W mod 2 is equal to 0. I will tell you the meaning of it. When you take the string, that is W, when you divide it with 2, always the remainder value should be equal to 0. That is what they are saying. Now W belongs to what here? W belongs to the alphabet A only. Only on A's we are going to do. Next problem we are going to see that the length should be both divisible, which consists of the alphabets A and B. Now, let us try to write the accepted strings for this given problem. The accepted strings can be, see, it can be epsilon also. Epsilon means what? 0. That is, it doesn't consist of any A's in it. Now, AA should be accepted because the length of the string is 2. 2 is divisible by 2. The remainder value will be 0. Similarly, I can write 4 A's. Again, 4 A's, if you divide it by 2, remainder value will be 0. Similarly, 6 A's and so on. 8A, 10A, 12A, like this. Now, I'll take a start state Q naught. Look at this. It is an example of a string whose length itself is 0. That is, the number of A's you have in this is what? 0 number of A's. So for that, what I am going to do, for the initial state itself, I will make it as a final state, Q naught. So from here, first string got accepted without any reading any input. Now let us go to the second string, A. Now what happens? Q naught to Q1 with first A, this one. Now to read the second string or the second alphabet, I'll put a reverse transition which can take the second A. So it is going back to Q naught. So this got accepted. Now I'll tell you why I made this as a loop. See, look at the fourth string, first A, second A, third A, fourth A, accepted. First A, second A, third A, fourth A, fifth A, sixth A, accepted. So this is the deterministic finite automata for a given problem. So I have written only two states for accepting the strings of A's whose length is divisible by 2. Now, if the same question they change it to two strings A and B, strings of A and A's and B's which are divisible by 2. What we are going to do? We are going to do a slight modification to this problem so that even that case will get accepted. So let me write that updation here only. Now I will tell you the string is having combination of both the characters A's and B's. When you take the length of it and divide it by 2, the remainder value should be what? 0. That means what? Accepted string. Again it can be epsilon. So this remains same. Next what is it? AB. It should be accepted because the length is what? 2. BA should be accepted. B should be accepted. A, it should get accepted. A, it should get accepted. B, it should get accepted, and so on. So what I am going to do, I am not going to make much changes here, but just I'll add B on both the transitions. What I am trying to tell here is, when you take a transition now, either you go with option A or you go with the second alphabet, that is B. You can take either A or B. So suppose, let us take an example of B, A. It should get accepted, right? The length is 4. So what happens? First time it will read B, here also it will read B, here also it will read B, and again it will read A and stop there. So that is how you are going to construct a DFA for a given problem whose length is divisible by 2. Now, the same problem, if I extend it in this way, construct a deterministic finite automata for W where the length of the string mod 3 is equal to 0. That means what? It should be divisible by 3. What are the strings here? What are the alphabets? Let us consider the alphabets as A, B only. Now, when this particular number was 2, how many states we got? 2 states. See here quickly. When this was 2, I got 2 states here. But now, when the number is changed to divisible by 3, what I am going to do? I am going to introduce one more state for it, and it is as simple as this. I am going to write Q0. I will make it as a final state. From Q0, you go to Q1 with first A, comma B, because the transition is on 2 alphabets, no? A, comma B. So from Q1, you go to Q2 with, what are the alphabets? A, comma B. Notice the length you got, 2, but it should be divisible by 3 all the time. So, I will write it like this with A, comma B. So, the first character, second character, third character, length is 3. If I go for one more loop, fourth character, fifth character, sixth character, divisible by 3. Seventh, eighth, ninth, divisible by 3. 9 is divisible by 3. So now, this is how we are going to construct a finite automata for such problems. Now here, in the same problem, if they change this particular value from 0 to 1, what we are supposed to do? So what they are trying to tell you in this particular problem is, whatever the string length you take, when you divide it by 3, the remainder value should be 1. That means what? See here, I will take 4 characters. Now what is the length of this? The length of this is 4. When I divide 4 with 3, what is the remainder value that I get? 1. So this should get accepted. Similarly, suppose if I take 7 values, A, B, B, A, B. See, this is 6 characters and this is the 7th character. If I divide 7 by 3, what is the mod value I get? 1. So basically they are telling you to accept the string of some particular length in such a way that when you divide it by 3, the remainder value should be 1. That means, what are the values that need to get accepted is, see, if it is mod 3, the values that need to get accepted is 0, 3, 6, 9, 12, and so on. If it is mod 3 value should become 1 for this problem. This is 0. If it has to become 1, just add 1 to it. That is 1, 4, 7, 10, 13, and so on. Correct? That means whatever the final state that I have made for this mod 3, it was because the starting string itself was 0. But here, what is the starting string length? 1, no? This final state should be shifted here. So for that, what I do, I will remove this final state that I have taken in the previous problem. I'll just make it as just a start state. So from year to year, the transitions will remain same, but I will shift the final state to this particular state. Now, let us quickly check whether it is accepting the length 4 or whether it is accepting the length 1. Yes, it is accepting the length 1. See here, if the string is A, it is accepting. If the string is B, it is accepting. If it is 4, first length, second length, third length, fourth length, it is accepting. If the string length is 7, 1, 2, 3, 4, 5, 6, 7, it is accepting. Now, if the same problem they change it to 2, what will be the final state? It is based on the same technique. This will remove from the final state. We'll mark it as Q1, a normal state. Final state will shift it to Q2 if this becomes 2. So, this particular video is solving multiple problems to you. Let me quickly revise it. First one, what is happening? For divisible by 2. Divisible by 2 problem can be asked in 2 different ways. Either they can directly tell it should be divisible by 2, or they can tell it should be having even number of length. So for that, what we did, we have constructed a DFA with only 2 states, so that 0 length is also accepted, 2 length is